Hello students, now let us see that this is the paper which has happened on the Monday. Okay, so this paper is Monday, on that is neat paper. I am taking the neat paper only. So that is what some instruction is there, student. What is the instruction? The test booklets consist of 180 questions. The maximum mark is 720. That is standard whatever the NTA is taking, student. Okay, NTA, that is accordingly this paper is designed. There are four, what they are saying, there are four parts in the question paper: physics, chemistry, botany, zoology, having 45 questions. In each parts equal weightage, each question allotted 4 marks for each correct. Okay, and for each incorrect 1 marks will be deducted. Mark only one correct answers out for the 4 alternative. Okay, this one: use blue, black ballpoint pen only for writing. Use of calculator not allowed. Dark the circle in the space provided. Don't like that, don't dark outside. Use the white fluid or any other material which damage the answer sheet is not permissible on the answer sheets. Okay, so these were the instruction. Now let us see, student, what are the problem. So first question is there: the gallium was named by Mendeleev. Okay, so three elements are there. Okay, firstly we are solving 46, you see, student. So what they are saying, gallium was named by Mendeleev. So that is three is first one was there, student, eka boron. Okay, so eka boron was made name is scandium, student, is scandium. Okay, I am giving little detail. And then next one is eka silicon was there, student, eka silicon. And eka silicon become the germanium. Okay, germanium after discovery. And another was there eka aluminum, student, eka aluminum. So eka aluminum become, student, gallium. Aluminum, it become the gallium. So you see, student, in the option gallium was named by Mendeleev eka aluminum. So correct option will be option number 1, student. Okay, now next problem, let us see, student. The problem number is there, problem number 47. What is the problem number 47, student? So 47 is saying the element of first B is called element of first B. अब student, you know this is the, if you know the periodic table, you can be able to answer this question very easily. And if you don't know, it's difficult to answer. Student, this is the periodic table. Okay, standard version. I am doing the diagrammatic of periodic table. So here if you see, this is the periodic table. Okay, and here will be the, this is the hydrogen and this is the helium. Okay, so these are the D block, student. These are P block. Here is the P block. Okay, and this is what, student, this is S block, and this is what, student, the D block, right? So when you are going to answer this question, so this is first A, first B, and here is what is that is second A will come, student. How 1 2 3 4, and here we can increase 5, and here is 1 is 6. So that is third A, third A, then will come fourth A, then will come fifth A, then will come 6A, and then will come that is 7A, and 0 group finally. And here will be what, student? Here if you go here, so this is the first B, this is the second B. Now this will be the third B, fourth B, fifth B, sixth B, 7B, and then it will be the eighth group. Okay, eighth group, right, student? So eighth group is having the 3 group. So where they are asking, that is first B belongs to where? So first B is the D block, and D block elements are also known as what, student? Transition element. D block elements are known as transition elements. Transition element. So let us see the correct option. Normal element, not alkaline, wrong. So transition element, option number B is required option, student. The group 18 or 0 group elements are best called noble gases. Okay, very easy, student. Now let us see the next problem, problem number 49. The number of waves made by second Bohr orbit of hydrogen atom is. Okay, so number of waves they are asking, students. So how you will be able to calculate this one? So number of waves, suppose second orbit they are asking, student. So that is, if you are going to orbit number and number of waves. So what is the rule is there? First orbit, if you talk about first orbit, so wave number of wave. Second orbit, no, orbit, second orbit, if you are going, student, that is 2. If you are going third orbit, so third orbit, that is 3 wave. Fourth orbit, fourth orbit, so fourth wave. What is meaning of this, student? Okay, this is the circle. So that is there will be only one wave will be there. If there is the atom is there, how many waves we will find, student? This will be the two wave like will come. For the third orbit, if you are going third orbit, so third orbit like this is there. So third orbit, how many will be there? Wave will be there. 1, 2, 3. For fourth orbit, if you are going, student, fourth orbit, so that is how many waves? 1, 2, 3, 4. This is the fourth. So correct option will be C, student. What is the question and what is the option? The number of waves made by the electron in second Bohr's orbit will be 2, student. So option number D is the correct option, student. Now let us move 50. The number of spectral line in visible region when an electron jump from 7th orbit to first orbit. So student, when the direct there is the number of spectral line, okay, a spectral line. So there is two formulas there, student, how to calculate for ground state, okay, for ground state, and another is there for all other state, for all other state, stat, for all other condition. So two formula is there, student, for all other condition. Even you can apply the for all the, this is applied for everyone, student. So this is n2 in bracket n2 minus 1 by 2. Number of spectral line will be n2 in bracket n2 minus 1 by 2. And here is what is number is equal to n2 minus n1 in another bracket n2 minus n1, okay, plus 1, and total divided by 2. So student, where electron is falling from the 7th orbit to first. 7th orbit to first means what is n2 is equal to 2 and n1 equal to 1. So what you will be able to do, student? So number of line is equal to n2 is equal to 7, 7 to ground state. So that is 7, another bracket 7 minus 1 by 2. So how much will come, student? 7 into 6 by 2. So 42 by 2. So how much is coming, student? This will come 21. Okay. And this formula also you can apply. This formula is for each and every case, student. So see, you will get same result. So n2 minus n1. n2 minus n1 will what is there, student? So that is 7 minus 1 in another bracket 7 minus 1 plus 1, right, student, by 2. So what is coming? 7 minus 1 means plus 6. And 7, this will be cancelled out into 7 by 2. So again 42 by 2. So again how much is coming, student? 71 line. So let us see where is the option, student. Option number D is the correct option, student. Now next let us move another problem. If radius of, question number 51, if radius of first Bohr orbit, of hydrogen is A naught, okay, then the de Broglie wavelength of in third orbit is, okay. So this is quite good question, student, that how can we be able to solve this type of question, okay. Let us try this one, what they are saying in this question. Question number 51 I am doing here on the bottom. So firstly let us erase this out. I need to erase full, student, because the space required is quite more. Okay, that's enough. Now let us move. What is their question? If the first Bohr, if the radius of first Bohr orbit of hydrogen is A naught, okay. So radius of first Bohr orbit, what is there, student? We know one formula, student. What formula? and then the de Broglie wavelength third Bohr orbit. So MVR is equal to NH by 2 pi. Okay, so for the first orbit, if you are going, student, for the, they are saying that is the radius of first Bohr orbit. Okay, so first Bohr orbit will be means what, student? 1h by 2 pi. And when you are going for third orbit, for third, so what will be there? MVR is equal to 3h by 2 pi. So how much will come, student? You see, it will be, you know uh, it will be 1 point, 3h by 2 pi, right? Now what you will be able to do, student, in this all the cases, what you will be able to do, hmm, MVR. So this you send this bottom line, student. So